Okay, so for Chapter 13, the ANOVA tests, one of the things you need to know is that the number of columns don't need to be the same, but in this case and in all the other cases they are. So what we're looking at is we have here different magazine types, and we want to see, do they all have the same length, the average number of pages, okay? And so our null and alternatives are always going to be the same. The null hypothesis is that they are all equal, and the alternative is that at least one is different, which means that at least two are not equal. So I prefer at least one is different, but that so at least something in the group is not equal to other things, and those are always going to be your null and alternative hypothesis for ANOVA tests. So in the degrees of freedom, there are two degrees of freedom. Depending upon what you're looking at, they call them different things. So in this book here, they call them the numerator. The numerator, degrees of freedom, is just one less than how many columns of groups of data there are. And then the denominator is the number of total things minus how many groups there were. So this here is going to be 4 minus 1. 4 minus 1. So the numerator degrees of freedom is how many columns there are minus 1. The denominator degrees of freedom is how many total things there were. So 1, 2, 3, 4, 5. There's 20 things minus how many groups there were. So the numerator is the group number of groups minus 1. The denominator is the number of total things looked at minus how many groups there were. And that's how you find the two degrees of freedom. There's actually a third, which is the degrees of freedom of total, which is these two things added up, which comes out to be the total number of things minus 1. And then to write it out, it's the Anova tests follow an F distribution. I don't know why they just don't call it an F test, but they don't. ANOVA stands for analysis of variance, and F is the distribution, with the numerator degrees of freedom followed by the denominator degrees of freedom. Okay, so to calculate the test statistic, we go to statistics and we put in all of the information. Okay, and once we have all of our information in, we go to Stat, Tests, and the last one is the Anova test. So we do Anova, and then we tell it where our columns are. So we have list 1, comma, list 2, comma, list 3, comma, list 4. And enter, and it does our Anova test. So here is our F statistic. Here's our test statistic, the F distribution. Here is the p-value. Now, we have to move this decimal point 4 places, so we get 0, 0.00099. But since we have to round to 4 decimal places, this here rounds up to 10, so therefore it looks like that. And as always, it's the probability of getting this test statistic if the null hypothesis was true. Okay, so there's less than a 0.001% chance of that happening. What does the graph look like? It's again always a greater than. Okay, so notice it's the only one that has greater than. And then what does it mean? What are we going to do? So alpha is 5% because our p-value is less than alpha. We reject the null hypothesis. So we reject the null hypothesis, and it shows that there's sufficient evidence to conclude that they don't have the same average number of lengths. And when we look over here at the rest of this, just so we can see that here's our degrees of freedom. Notice it calls it factor, the numerator, and then the denominator they call error. So there's our 2 degrees of freedom. And all of these pieces here are used to calculate this statistic. This is just a ratio of our mean squares and our mean squares of the error. Like when we divide those, we would get that we would get that 9. So that's how also all this stuff is working to find all those little pieces. But all the homework cares about is just the test statistics. So, all right. I hope that was helpful, and I will see you on Saturday.